Hey everybody, Mr. Hayes, Hayes' World of Math. We're back in my basement. Welcome to 2020. We're talking through the latest set of notes that we're going to talk about difference of proportions with significance tests. As always, you can follow along. I've put a copy of the notes down here in the link. Pause where you need to. We'll talk about all of this, and this should hopefully keep us on track for those of you with me in class who are having an e-learning day today. So this setup is new this year, so we're going to kind of go through this. In a simple card game, a dealer shuffles the cards, and then the randomly player selects a card, and you have to predict if it's going to be red or black. Player returns the card to the deck, you mix them back up again, you just keep going and going and going for 20 cards. Lindsay plays the game and gets 14 out of 20 correct. Notice I've already put that as P hat 1, or P1 hat. And then Luke plays the game and gets 10 out of 20, and I'm putting that down as P2 hat. Luke believes they're both equally skilled and that this result happened purely by chance. So let's talk through this. So your statistic here is that it's P1 minus P2, and that's the true difference in proportion of correct guesses. Lindsay's minus Luke's. Now, again, we're starting off very basic on here. Some of you may want to jump straight into null hypothesis, etc. Let's start this a little bit more basic. I need to scroll this up so you can see it from behind my head. Luke's claiming that P1 minus P2 is 0. Lindsay's claiming that that's not true, that in fact P1 minus P2 is going to be bigger than 0. In class, we would go through and you'd have pairs of you guys off, you'd have decks of cards, you mix them all up, and you play the game. You would do 20, your partner would do 20, and then you would go through and see who did better. These are two simulations here. I got one which had a 5% difference. The player 1 was ahead, the other one got negative 10. And this is similar to data that I've seen from other teachers. So here's a sampling distribution of P1 hat minus P2 hat. Now notice a couple of things here. We would normally say our difference is 20%. So we're going to go bigger than, so we had a proportion of roughly about a little bit bigger than 10%, almost 11%. That we had 3 out of the 28 had proportions as great as Lindsay had or better. And again, we've done this before. This shouldn't be totally new. So a couple of things as reminders. What does each dot represent? So again, we're assuming that the null hypothesis is in fact true. So that P1 minus P2 hat, or P2 is 0. And so if that was true, we have a 0.107 probability, so a 10.7% probability of seeing what we're seeing, that we saw that it had a P1 hat minus P2 hat of 20% or greater, purely by chance. So in other words, in this case here, yeah, it was probably chance. Nice try, Lindsay. And then down over here, does this observed result give convincing evidence? All of this should be very relatable to what we've been doing with single proportions. So if it sounds really familiar, there's that. And we're also going to take a little bit of what we were doing with confidence intervals. So hopefully this doesn't come across as too difficult. So your hypotheses, you've got a couple of this way. And I think this is helpful in terms of, how can I say it? It's in terms of interpreting it at the very end, which one's better. However, I always found it confusing in terms of setting up your hypotheses like this. So this is going to be, this purple area here is just set up so you can kind of see what the relationship from P1 to P2 is instead of just doing the difference. In terms of the conclusion, again, 2 parts. We need to interpret what the p-value is, and then we're going to have to make a decision on that. So in terms of interpreting, we start having things here. So like here for the conclusion, because the p-value is less than our alpha value, and the alpha value is going to be that significance level of 5%, sometimes 1%, depending upon the situation, we reject the null hypothesis. We have convincing evidence for the alternative. So we basically say, yeah, everything that we saw, if it was done by chance, there's no way it could have really happened. So the alternative must be going on. There must be something influencing our results. Now, if that p-value is not less than, okay, so our first of all, P1 minus P2 is 0. And we're trying to see here, is there satisfying that the people for college graduate, Okay, so is there a convincing sorry. So we're trying to see, is there a difference? So this is basically two-sided. We're not going to run through all the math on this, but notice here, we're just trying to see, is there a difference between college graduates and non-college graduates? So P1 minus P2 is 0. And then the alternative hypothesis is that it's not equal to 0. But now again, remember, we do have to define what P1 minus P2 is. So it's the true difference of proportion that are satisfied with their personal lives. And then I say college grads minus not college grads. Do we have some evidence for this? Well, yeah, because the situation would be this. Assuming that the null hypothesis is true, that there is no difference, there is a 0.004 probability of seeing a difference in proportion that are satisfied with their personal lives for all college grads and all not college grads. So because of that, the conclusion that we can make is that of non-college grads. There. That should work better. So hopefully that helps some. Again, if you have questions, drop below, like, comment, subscribe, all that other stuff. Some other videos over here that hopefully you'll find helpful, and we will see you later. Enjoy your day.